I've had it in mind to make a Wi-Fi mesh around the property, and I'm keen to try these little ESP01Ss, and even more keen to maybe run it from solar power. So having something like an 18650 battery, or maybe a couple of AA nickel metal hydrides, not really sure, but then run it through this charge controller, and then off to, well, in this case, this is a 3.3 volt regulator, and then onto the actual device itself. But I'm curious as to know which of these would be the best option. I mean, I've only used sort of like these guys before. These are little guys, what's that, 54 by 54 millimeters and a couple of volts, so clearly not adequate. Then I've got these ones here, which is, what's that, that's 90 by 60 and 6 volts. This is 90 by 60 as well and 5 volts. Then we go, this one here is, what's that, 100 by 70 millimeters, and that's 5 volts. This is a bit of a curious cat. That's 110 by 60, but no rating on there, so I'd be keen to test that one. These ones have just come in from a recent mailbag, so that is 142 millimeters by 88 millimeters and 5 volts. And then I've even got this giant one and one only, which is 120 millimeters by 194, and no voltage mentioned on that at all. So my plan is to make a circuit with maybe one of these resistors. These are, I think it's like 10 ohms or 20 ohms or something like that, so quite low resistance. And I'll just put a little circuit together. There's some sunshine around at the moment, which is amazing. Do a measurement of the voltage coming out and the current through this across these resistors, and should be able to therefore work out a power rating for each of these, and that should give me an indication of whether or not this circuit is going to work. So that's the plan. I'll solder these up, get them out into some sunshine, make some measurements. The sun does vary a little bit down here in Tasmania, so maybe we need some sort of device constructed to maybe correct for the pitch. So I'm just thinking that I could use some materials I've got laying around here to make, I don't know, sort of a pitched box of some sort, maybe, that you could put the solar panel, let's say, here, and feed the wires through to do the measurements on the other side, and then the sun's rays, you know, shine down here. So I'm thinking maybe something that looks a little bit like a cross. Yeah, so something like that maybe, and then it folds up like that, and these sides fold in, and then maybe it's got, you know, little flaps here which fall into, you know, some sort of pattern like this for one side and the other, and then as it folds up and folds up, it'll produce something like that. So there's going to be a lot of calculations and things like that involved in this whole process, and I'm a little worried. Although, having said that, I've just received a supply of supercomputers, so that might help with that. So let me just check that out. So this has come in, and I believe it's the supercomputer that I ordered to do calculations like, you know, the power output, the angle of the sun. There's a lot of different things to consider. Let's have a look. I didn't expect this to turn into a sort of a mailbag, but it's just timely is all. So let's just grab that and have a look. It's well packed. Well, as you'd expect for a supercomputer. Wow. Oh, okay, so that's not a supercomputer. Aha, but look at this. Wow. Yeah, so I reckon we can do calculations like 5 times 6 if we need to. I can't imagine what that would be. It's a pretty big number. Okay, 30. So these seem to work pretty well. So that's timely to help me do the calculations. And as for these things, that might come in handy as well for this project. My apprentice says, get this show on the road. So let's do that. So we've got our numbered panels here, all the different sizes, and then what we'll do is just record what the Solar Tester 6000 Mark II says, and see which one's going to be best for the Wi-Fi mesh. What do you think about that? Amber says, yeah, let's go. I was feeling pretty happy with the Solar Tester 6000 Mark II yesterday, and in fact used it to make a heap of measurements on the 6 candidate solar panels that I had lined up, and went ahead and made all those measurements. So let's just have a look at that for a minute or so. Can you see that? That's so that the electrons are aligned. I don't know what that's about, actually. Anyway, we've got 4.8 volts and 0.1 amps. Yep, nice. All right, let's write that one down. Coming along to our test bench here. That's number 1, so we've measured is 4.8 and 0.1. All right, good start. Number 2, measuring, some interesting effects, 5.3 volts and 0.11 amps. Nice. Number 4, 5.5 volts, up to 0.12 amps. Nice. That's pretty promising. So I made all those measurements and selected a solar panel based on that, but there was, I don't know, there was a little bit of a spidey sense thing going on, and I think it had to do with the fixed load. That's a 10 ohm resistor in there at the moment in that rat's nest. But yesterday I had a 150 ohm resistor as a bog standard load across all of those solar panels. And so I was a little bit concerned that I wasn't getting a range of results. And I think it's because if the circuit's open, then your solar panel will provide sort of like a maximum potential across the 2 wires here. But if you close it and you put it in with a load, then that voltage may drop off depending on what that load is. So what happens is that as that load increases, the current will get to this current versus the voltage ratio will get to a sweet spot, and you'll get like the maximum power out of it, and then it'll start to tail off as that load increases. So I wasn't seeing any of that really. It was just fixed, and yeah, I didn't really feel that happy about it. So what I've done is I've put in series with that 10 ohm resistor, I've put this little 1K pot. And what I propose to do is to actually vary that, and you'll see the resistance rise on the meter to the right there. And so I can maybe take a series of measurements for each solar panel and see if I can get that sweet spot rather than just saying, oh, okay, here is the load, good luck. That might give me a better indication of what's happening with these solar panels with different loads, and that's probably more relevant than just having a standard load and just taking that as read. So I'm going to redo all of these, and we'll come back and have a look and see what that looks like. Well, the sun's only coming out briefly today, so I'll have to do this test on a sunnier day. But just to show you how it's going to work, so we've got 15 ohms here. You may not be able to read this okay, but I'll read out the numbers for you. So 15 ohms coming in. When we plug in our solar panel, have we got is it actually working? Oh yeah, look at that, we can see the lights flashing. We have 0.6 volts and 40 milliamps. So that's obviously a big voltage drop. A lot of current going through and dragging the voltage down, and then so you're past that point of maximum power for that solar panel. Let's change the load, so we'll dial this up to, let's say, around 50, that's 47-ish ohms. So we'll plug this in, and we've got 50 milliamps and 1.9 volts. Just bear in mind that the sun is actually not shining at the moment though. Here it comes back. So around 3.3 volts, 3 volts and 80 milliamps. So now we'll change the resistance. That's around 90 ohms now. And we've got 3.6 volts here and 50 milliamps. So I'll record, here the sun's coming out, so now it's going up to 4.6 and 60 milliamps. So I'll take a whole series of readings for each of these in full sunshine, if the full sunshine ever returns, and then we'll have a look and see if we can't graph them and find the maximum power output for all of those solar panel options. Here's the data collected by the Solar Tester 6000 Mark II on the 5 candidate solar panels that I looked at. So I've just got each solar panel listed here, size and voltage. Then I've got a column with the load, so that's the resistance in ohms, the voltage and the current in amps. And I've just multiplied those last two together to get the power, in this case in milliwatts. And then I have graphed them for each of those solar panels. And you can see that classic curve coming out that we saw earlier on the theoretical one. In fact, if I overlay a curve onto all of these, you can see that pretty much does follow the expectation. The disappointing thing is the resolution, not enough data points. And that's probably due to two things. One was the 1K potentiometer that I used, which didn't allow for very fine readings. It was actually difficult to adjust, and it did drift a little bit too because of that. So I'd like to probably use something like a 100 ohm pot or maybe a 220 ohm pot. And the other thing I'd like to do is to use something like an Arduino, or perhaps better still an ESP8266 or maybe an ESP32. And using a voltage divider, and the ADC on that, I can work out the resistance, I can measure the volts and the current, and I can maybe pump all that data out to the internet and maybe collect, like 100 points would be great. And then I think I'll be able to see this peak power output for each of these panels a lot better. So perhaps there'll be a Solar Tester 6000 Mark III in the near future, but for now that is the circuit working, and I will see you next week.